Hey everyone, I am Ritik from the Department of Computer Science at the University of British Columbia, and I'm excited to present Look2React, making VR NPCs come alive with dynamic vision guided reactions.
Today, we have several games pushing the boundaries of interaction in VR, giving players more control over their characters and virtual environments than ever before. However, the NPCs or the non player characters still don't respond convincingly to this control. Current systems are limited to specific triggers and events as shown in the still from a popular AAA game. The guards would look at you making a fist and approaching them, but won't do anything unless you physically interact with him. This breaks immersion, and we want to fix it. Research has well established that players appreciate and pay attention to these NPC interactions, often favoring them at the expense of task performance to increase enjoyment. Research has also shown that players are aware of themselves in VR and have expectations of how others should respond based on their physical cues, and when NPCs don't meet these expectations, immersion is shattered. To enable open ended interactions, researchers have incorporated various LLM solutions into virtual worlds. They have already shown the effectiveness of LLMs to handle interactions when provided with direct context, like through voice chat or environment tokenizations. With this work, we wanted to take that a step further, and we started with three research questions. Question 1. How can relevant pose data and user and environmental context be conveyed to a multimodal LLM for better player NPC interactions? Question 2. What is the viability and performance of such a system in generating dynamic NPC reactions in role-play scenarios based on provided environmental and user context? Question 3. What impact do dynamic NPC reactions have on players' immersiveness and engagement in VR games? To answer research question 1, we built Look2React, a vision model-based NPC interaction system that allows the NPCs to see the environment and the player and respond accordingly. Here is Look2React in action. Players walk up to an NPC and perform an action, which the system captures from the NPC's perspective and sends them to a VLM to generate a text response and select a gesture response. Now, since this is a VLM-based solution, we had to optimize cost and also ensure the interactions felt natural. So we adopted a 4-step trigger mechanism inspired from stealth games. Players walk up to an idle NPC, and when they are close enough and start looking at it, the NPC also starts looking. This is indicated by the eye opening over the head and starts gradually filling up with yellow. When the eye is completely filled with yellow, the NPC starts thinking for a response, which is displayed when the eye turns red. As with all LLM-based systems, the prompt is very important. This is the prompt that we use. For each interaction, we provide the NPC type, the list of available gestures in the game engine that the NPC can respond with, previous response text to ensure variation in text responses, and 3 images of the environment from the NPC's perspective. We designed this to be highly cacheable across different NPCs to optimize token costs. The only change across NPCs is the NPC type parameter, which we will discuss in more detail very soon. With the image context, Look2React NPCs can respond naturally to any gestures the players make. They can also respond to any items in the environment the player may have equipped. But not only this, Look2React NPCs can understand subtle player gestures like when the player is playing a guitar versus when they are posing with it and respond to them accordingly. In addition to that, the NPC type parameter allows Look2React NPCs to respond according to their personality, meaning completely different responses to similar actions, making the NPCs feel truly alive. Now, to really test Look2React, we conducted a user study with 20 participants. We created 2 versions of an open world RPG game, one with traditional NPCs found in games today, and one with Look2React NPCs. Each participant played both versions of the game. We asked participants to fill out a game experience questionnaire after each session, and we conducted a semi-structured interview at the end of both the sessions. The main task the participants were asked to do was a fetch quest, and in true open world fashion, they could interact with 3 NPCs placed in the world and equip several items. The players were free to play the game as long as they wanted to. Now, looking at the results, we first look at how the VLM performed. Since the VLM is the backbone of Look2React, we chose OpenAI's GPT-5 Mini for our user study. Average response or thinking times were between 5 and 9 seconds, and average token costs were around 1400 tokens per interaction, which comes out to around $1 per 3000 interactions by today's token costs. Moving on to the play sessions, Look2React play sessions were almost twice as long as compared to the control. However, since Look2React interactions are significantly longer than traditional ones, this metric doesn't give us the complete picture. Total interaction counts can help, but since traditional interactions were simply button presses, players would often spam the button multiple times in a few seconds. To help with this, we devised a new metric, repeat interaction count, which we define as the number of times the player comes back to an NPC having walked away to do anything like talking to someone else or picking an item. Look2React had almost twice the number of repeat interactions compared to control. Our GEQ scores also show how Look2React NPCs felt more real and social, with Look2React NPCs scoring significantly higher in all segments of the social presence questionnaire. Similarly, for the in-game section, Look2React NPCs scored higher in all sections except the reverse-coded ones where it scored lower. Now coming to the interview, we can learn how the players felt about Look2React NPCs. Several players noted that the two personalities had a stark difference. Where the girl was perceived as outgoing and upbeat, the guard felt dominant and aggressive. These comments demonstrate that even a short 2 to 3 phrase parameter adjustment can effectively establish distinct and convincing personalities. Finally, we present an excerpt from participant 7's interview, which succinctly captures what we envisioned Look2React to be. They explain how their feeling towards the guard shifted in response to the NPC's behavior, leading them to experience a personal side story that wasn't scripted in the game but felt uniquely their own. Wrapping up, for research question 1, we identified VLMs as the most effective for capturing and analyzing player and environmental cues and present Look2React. We use objective metrics like latency, token usage, and interaction patterns to complement subjective measures like personality, immersion, and engagement to show Look2React efficiency and believability. Finally, through questionnaire and interviews, we learn how Look2React powered dynamic NPC reactions increase immersion and enjoyment in virtual RPG scenarios. Looking ahead, these are some opportunities our team would focus on. Slow and fast approaches by combining physics-based or local LLMs to reduce latency. Implementing Look2React in multiplayer and shared spaces to study group dynamics. Per NPC memory for longer-term consistency between interactions, and looking into other mediums like flat-screen gaming where Look2React may help.
We hope you enjoyed this presentation as much as we enjoyed creating Look2React. Please feel free to reach out with any questions or comments. Thank you.